Good day, math learners. For this week, we will be talking on the discrete probability distribution. For this table, we have the discrete probability distribution. As you can see in the first column, these are the possible outcomes when you toss a coin twice. So it can be head, head and tail and head, and tail, tail. In the second column, it shows the number of tails, which is considered as the value of the random variable x. So we have 0, 1, 1, and 2. The table shows us that there are 3 values of the random variable x. The third column shows the probability. In notation, the probability of the values of the random variable shall be P of the uppercase x is equal to the lowercase x is equal to any value of the random variable. So, please take note, class, that the uppercase x is considered as the random variable and the lowercase x is the possible value of the random variable. So we are going to write the notation of the probability of the values of the random variable based on the given table. First, for h and h, the notation is this. P, or the probability of the random variable, or the uppercase x, equals possible value of the random variable, or the lowercase x, equals 0 because the number of tails are not present there. So the answer is equal to 1/4. 1 is in the numerator because there is one possible answer for head and head, and 4 in the denominator because there are 4 possible outcomes. For the second one, we have h and t. The probability of the random variable, or the uppercase x, equals the possible value of the random variable, or the lowercase x, equals 1. 1 because the number of tails is 1. And the answer is 2/4. Why do we have 2/4? Because there are 2 outcomes with a probability of 1/4 that can give us 1 tail. So we have here as well. Therefore, we will add the probability. So we will be adding that, and the result will be 2/4. Or simplify that 2/4 and the answer is 1/2. Now, for the third one, or for the last one, is considered as the probability of the random variable, or the uppercase x, equals possible value of the random variable, or the lowercase x, equals 2, and the answer is 1/4. Why do we have 1/4? Because again, there is only one possible outcome for t and t, or for the tail and tail, and we have 4 here as our denominator because there are 4 possible outcomes there. Please take note, class, that a table, graph, or formula that lists all the possible values of the random variable and the corresponding probability for each value is called a probability mass function, or probability distribution. A list consisting all the possible values of a discrete random variable with its corresponding probability is called discrete probability distribution. Just like what I have presented to you, the table earlier. A distribution is considered a discrete probability distribution if it satisfies the following properties. First, the probability of each value is between or equal to 0 and 1. In symbols, we write it as the probability of the random variable is less than or equal to 1, but greater than or equal to 0. The second property is the sum of the probabilities is 1. In symbol, this one. The summation of the probabilities of the random variables is equal to 1. Please take note of the symbols, class, that this uppercase sigma is read as the summation of, and this symbol is read as therefore. For example number 1, using our example on tossing a coin twice, consider the following table as a summary of table 1. If the value of the random variable is 0, then its probability is 1/4. If the value of the random variable is 1, then its probability is 1/2. If the value of the random variable is 2, then its probability is 1/4. Let's check if the table above is a discrete probability distribution or not. So, the probabilities 1/4, 1/2, and 1/4 are all between 0 and 1. So, the first property is satisfied. Next, the summation of the probabilities, which is equal to 1/4 plus 1/2 plus 1/4, the answer is equal to 1. So, the second property is still satisfied. Therefore, the distribution is a discrete probability distribution. For example number 2, when two fair dice are thrown simultaneously, the following are the possible outcomes. We define the random variable x as the sum of two outcomes in the throwing of the two dice. So the possible values of the random x are 2. Why 2? Because 1 plus 1, the answer is 2. We have also 3. 1 plus 2, the answer is 3. We have 4, we have 5, 6, 7, 8, 9, 10, 11, and 12. So we will use this example number 2 to find the probability of the random variable with the possible values of 3, 5, 6, and 12 as the sum of the two fair dice being thrown. So, the solution, in rolling two dice simultaneously, we have 36 possible outcomes. First, we write the notation. P of the uppercase x, or the random variable, equals the lowercase x equals 3 as the possible outcome for the sum of the two fair dice being thrown. Okay, equals, so we have 1, 2, and 2, and 1. Why do we have that 1? Because if we are going to add 1 and 2 and 2 in 1, the answer would be 3. So do we still have other possible outcomes that the sum is 3? Okay, there's none already. So the probability of the random variable with a possible value of 3 is considered as 2 over 36. 2 is in our numerator because there are two pairs whose sum is 3, the 1 and 2 and 2 and 1. So we have also 36 is the denominator because we have 36 possible outcomes all in all, or 1 over 18 as the final answer. So next is P of 5, or the possible value of 5. We write the notation first. P of uppercase x, or the random variable, equals lowercase x equals 5 as the possible outcome for the sum of the two fair dice being thrown, equals P of 1, 4 plus P of 2, 3 plus P of 3, 2 plus P of 4, 1. So we have these possible outcomes because when we are going to add 1 and 4, the answer is 5. When we are going to add 2 and 3, the answer is 5. When we are going to add 3 and 2, the answer is 5. And when we are going to add 4 and 1, the answer is 5. Or all pink colors are said to be the sum of our value, which is 5. And then the probability of our random variable is 4 over 36. 4 because there are 4 pairs whose sum is 5, such as 1 4, 2 3, 3 2, and 4 1. And 36 is the denominator because we have 36 possible outcomes all in all. Or simplify them further and we will be getting 1 over 9 as the final answer. So our next solution is to construct the discrete probability distribution in tabular form and check if the distribution satisfies the properties of DPDs. So, if we are going to continue finding the probabilities of the possible values from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So, the P of x, or the probability of a number whose sum is 2, is equal to 1 over 36. The probability of a number whose sum is 3 is equal to 1 over 18. The probability of a number whose sum is 4 is equal to 1 over 12. The probability of a number whose sum is 5 is equal to 1 over 9. The probability of a number whose sum is 6 is equal to 5 over 36. The probability of a number whose sum is 7 is equal to 1 over 6. The probability of a number whose sum is 8 is equal to 5 over 36. The probability of a number whose sum is 9 is equal to 1 over 9. The probability of a number whose sum is 10 is equal to 1 over 12. The probability of a number whose sum is 11 is equal to 1 over 18. And the probability of a number whose sum is 12 is equal to 1 over 36. So let's check if this set of probabilities is under the discrete probability distribution by satisfying the first and second properties of the DPD, or the discrete probability distribution. So the probabilities are all proper fractions. So their values are between 0 and 1. Why? Because 1 over 36 is less than 1 but greater than 0. 1 over 18 is less than 1 but greater than 0, and so on and so forth. So the first property is satisfied. Next, the summation of P of x, or the probabilities of the random variables, are 1 over 36 plus 1 over 18 plus 1 over 12 plus 1 over 9 plus 5 over 36 plus 1 over 6 plus 5 over 36 plus 1 over 9 plus 1 over 12 plus 1 over 18 plus 1 over 36 is equal to 1. So the second property is satisfied. Therefore, the distribution is a discrete probability distribution. For example number 3, the spinner below is divided into 8 sections. Let Z be the score where the arrow lands. So, construct a probability distribution for the random variable Z and check if the distribution is discrete probability distribution. The solutions: when we study the spinner, the possible values of the random variable Z are 1, 2, 3, and 4. Okay, so in our table, the P of Z, or the probability of a number 1, is 3 over 8. 3 is in the numerator because there are 3 possible outcomes for 1. So we have 1, 2, and 3. So that is why we have 3 here. And 8 is our denominator because the totality of all possible outcomes in our spinner is 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that is why we have 3 over 8 as our probability of a number 1. Next, the probability of a number 2 is 2 over 8. 2 is in the numerator because there are 2 possible outcomes for 2. So we have 1 and 2. And 8 here is our denominator for the totality of the possible outcomes of the spinner. Next, the probability of a number 3 is 2 over 8. 2 is in the numerator because there are 2 possible outcomes for 3. And 8 is the denominator. And lastly, the probability of a number 4 is 1 over 8. 1 is in the numerator because there is only one possible outcome for 4. So, and we have here. And 8 is the denominator because this is the totality of all possible outcomes in the spinner. So, this time, let's check if this set of probabilities is under the discrete probability distribution by satisfying the first and second properties of the DPD, or the discrete probability distribution. So we have 3 over 8 is less than 1 but greater than 0. 2 over 8 is less than 1 but greater than 0. We have also that. 1 over 8 is less than 1 but greater than 0. So, the first property is considered satisfied. The second property, so we have to consider this summation of the probability of the random variable z. So we have 3 over 8 plus 2 over 8 plus 2 over 8 plus 1 over 8, and that is equal to 1, which is considered satisfied. Therefore, the distribution is a discrete probability distribution. Thank you for listening, math learners.